Can I? Yeah, I'm just filming this.
Okay.
Sorry. Thank you. This question's about investigating the efficiency of an electric motor. So we've got the motor here, and this is the motor shaft which is going to spin. A string's attached to it with a mass hanging off it, and the motor is going to be clamped onto the workbench. So she uses the motor to lift the mass, and then this table shows her measurements. So we've got the current in amps, the voltage in volts, the time taken to lift it in seconds, the force needed to lift it in newtons, and the distance that it is lifted by in meters. So all the units are as we'd want them. We haven't got any millivolts or milliamps or kilonewtons or kilometers or anything like that. So we can leave them as they are. Now part A asks us to calculate the electrical energy supplied to the motor during this time. Now, this is one of the questions that's actually on the exam sheet, so you don't have to remember it, but I recommend that you do. And it's that electrical energy is equal to the voltage multiplied by the current multiplied by the time. And so it's a really simple question. We're just going to substitute in all these values, calculate the final value and get the energy supplied. So we've got 10.3 volts multiplied by 1.3 amps and then multiplied by 4.7 seconds. We put that into our calculator and we're going to get 63 joules of energy supplied to the motor during that time. Next part of the question is state the equation linking work done, force and distance moved. So again, it's another one you have to memorize, and it's work done is equal to force times the distance moved. Next part, it asks you to calculate the work done on the mass. So, as always with these types of questions, we're going to use the equation we just had to state. So work done equals force times distance. Right, let's find the force, it's 20 newtons. Let's find the distance, it's 0.85 meters. Put that into your calculator and you find that it's 17 joules. Next part of the question. State the useful energy transferred to the mass. Now notice it's only one mark available. So we're not having to calculate anything, otherwise it would have told us to. The number is staring us right in the face, and that number is 17, because the work done is in lifting the mass up. That's the whole point of the motor. So that is the useful energy transferred. So the useful energy transferred is 17 joules. Next part of the question. Again, we're stating the equation linking efficiency, useful energy output, and total energy input. So efficiency is equal to useful output divided by total input. Now you can leave it like that, or you can, if you want it as a percentage, multiply it by 100. But that's only if you want it as a percentage. It doesn't matter which way around. Next part, as always, we're going to use the equation that we've just stated to calculate something, and that's the efficiency. So our efficiency is going to be equal to the useful output divided by the total input. So the useful output we've just worked out here, that's 17. The input we worked out here, that's 63. And so we put those two numbers into our calculator and we're going to get 0.27, or if we were to use the percentage version of the equation, we get 27%, but I'm just going to leave it at 0.27. There it is, another easy 9 marks.